Bismillahirrahmanirrahim. So we are going to solve this problem. This is a CP assigned by Sarahat. The first one, set to appropriate foundation design parameter. We need to select the correlation from the based on the literature to find out the cohesion and friction angles from the SPTN values for the each layers. And second one, to proportion the foundation proportion curves. Okay. And then to find out the settlement foundation at the different soil layers. So I am going to solve for the group 3 data. So this is the SPTN values data, geotechnical investigation data. So let's start at 2 meter. We are going to place foundation at 2 meter depth from the NSL level. So at 2 meter, this is the SPTN value is 4, 2, and 8. So as these are not very close values, so we are going to take the minimum value. So 2 is the minimum value that is be taken here. Depth of foundation 2 meter, SPTN value 2, and gamma 15 meter cube was selected from the given by Russell along with this problem. At 2 meter depth, the dry density gamma d is equal to 15 meter per cube, kilonewton per meter cube. So we are going to use this. Q becomes equal to gamma df. This is the correlation we use based on the literature. Cohesion, you can use yours. And first in the first trial, the width and length assumed to 1 millimeter. NC, NQ, and gamma was selected from the Terzaghi bearing tables we have used in the here. You can choose NC, NQ, and gamma from your this and shape factor based on these formulas, depth factor and inclination factor. As the load is axially, we assume the load is axially applying on the foundation, and the over Q net pressure assumed that is given by the instructor was the 100 kPa, and the general bearing capacity question used this, and this comes out to be 2.2 into 10 raised by 3 kPa. Factor of safety was found from distillation that that comes out to be 22, and Q allowable, Q ultimate minus Q overburden. Q allowable becomes 2.18 and raised by 3 kPa. So here we have find out the ultimate bearing capacity and allowable bearing capacity. Next, to find out the settlement. So first of all, need to check this influence zone. Influence zone is equal to 4b or 5b. As we have set b is equal to 1 meter, so influence zone becomes the 4b into becomes the 4 meter or 5 meter, means 4 meter or 5 meter you need to go below the foundation depth to check out the settlement. So it depends on how much soil layers are present below the depth of the foundation. If we have, as we have set the foundation at 2 meter depth, and we are going to find out the settlement at 7 meter. H become H1 means H1 from the bed of the foundation to the soil layer where we are going to find out the settlement. H1 plus depth of the foundation is equal to 2 meters. So total depth from the ground level becomes the 3 meter. 3 meter we have the silty clay or silty sand. And as we going to increase H1, 2, 3, 4 to H7, which was 2B, for 4B or 5B. So these are the soil layers 1, 2, 3, and 4. So corresponding to each soil layers need to calculate the settlement. So how we calculate settlement depends upon the soil layer's nature. If this is soil, if the soil is clay, it has a different method. If the soil is a silty sand, it has a different method to find out the settlement. As it was selected, h is equal to 1. So depth of that layer from the ground level becomes 2 plus 1. 2 here is the depth of the foundation, and 1 is h, becomes equal to 3 meter from the ground level. At that 3 meter we have silty clay, so we use that method to find out the settlement. B prime, this h is equal to 1 meter, this, and at that 3 meter soil layer have a SPT in a value 9, and ES was selected from the design parameter provided by the sir. SPT in value if less than 5, ES is equal to 3 megapascal. If SPT in value 10, the ES will be 8 megapascal. So this was the use. Poisson ratio was selected from the based on the literature. 0.25 to 0.35 was is the range. So we selected 0.3. M prime and N prime was used to calculate the settlement of effective settlement. For center of the footing, alpha is equal to 4. M1 and N prime and N prime calculated from this formula to find out the F1 and F2. F1, F2 are the parameters used in the calculation of the settlement. This is the M prime, this is the N prime. Find out the F1. M prime, N prime correspondence gives the F1. Same for the M prime, N prime correspondence give us the F2. F1, F2 was selected from that, and then F1, F2 based on these and Poisson ratio IS calculated. Now how we calculate the IF? IF depends upon the depth of the foundation, the ratio, and some other things. Let's check. Let me see. Let me open the slide to show you what is the IF. This is the IF, depth of foundation over B and length of foundation over B. From this we will calculate the IF. Poisson ratio 0.3. As here is the IF calculated from this. Depth of foundation over B, the ratio, and length of foundation over width ratio gives us these curves. By intersecting these values, we will calculate the IF. So this was calculated, and it was put it here IF 0.56. Here we able to calculate the IF IAC. Now need to calculate the net pressure at that soil layers. So if we, for example, this is the foundation bed, we are going to 1 meter below. Need to calculate the effective stress at that point. So this we use the concept from Geotech 2 to calculate the effective stress, that was sigma z is equal to q net influence factor IZ. I influence is a depth influence factor that was comes out from this table, corresponding to N and M. We will calculate the I4, which is IZ. N is equal to B over Z, and M is equal to A over Z. So these relation as also put it over here, N and M. These relation give us the IZ from taken from this chart, and then sigma g calculated, which was comes out to be 17.5 kPa. For using this net pressure and using this shape factor, this depth factor, the settlement calculated, which was then converted to millimeter, is 0.55 millimeter. So up to now we have calculated the settlement immediate settlement at the one layer, which was the Celtic layer. Now h is equal to 2. At h is equal to 2, 2 is it's the same depth of the foundation, and the h2 comes out to be 4 meter. At 4 meter we have silty sand. Silty sand got the SPT value from same file, and again calculated the depth. This formula we are present in the slides. uh, Now again to calculate the net pressure, n and m calculated from n and m, iz calculated from the tables, and net pressure calculated. From these input values we calculated the settlement at that layer, which comes out to be 0.63 millimeter. Now again h is equal to 3 meter. The same procedure will be repeated to calculate the settlement at that layer, which is present at h is equal to 3 meter. That comes out to be 0.281 millimeter. So then h is equal to 4 meter. We will continue this procedure until we reached our 4B zone. I mean, again repeating, the 4B zone means for B, here is the width of the foundation. We have assumed in the start of the analysis. 4B zone until 4B zone, that soil responsible for the complete settlement. As here is not water table present in our 4B zone, so primary consolidation and then the secondary consolidation will not happen. So only immediate settlement will be responsible for the settlement of the structure. So all these settlemented calculated, we calculated this total settlement, which is sum of all these. This is what that comes out to be 1.615 millimeter. This is the settlement at 4B zone moves calculated. This is by repeating this procedure you can find out the all the other all the settlement and other means. uh, and next step we will go to increase our the length or width ratio. Means you can increase the length to 1 to 2, and third step you will increase again 1 unit to 3 meter. And by repeating the same procedure, you will again calculate the ultimate bearing capacity, factor of safety, allowable bearing capacity, and again settlements until uh, these values will go view the settlement and ultimate bearing capacity, factor of safety relations. Then again the second procedure is to increase the depth. Depth will be the, you can go to 4 meter or 3 meter, and then at each depth you need to calculate the 2 to 3 width relations. Means if we have set the depth equal to 2 meter, the length will be 1, then 2 meter, then 3 meter. So that we can calculate the, so can we assume the, we can check the what is the behavior of the length and width on the settlement and the ultimate bearing capacity. This is all from this.